Welcome to today's tutorial. In this tutorial, we are going to discuss how we can evaluate sets, how we can simplify and evaluate sets. Alright, so if you have not yet subscribed to the channel, make sure that you click on the subscription button and the notification button so that you don't miss out the videos that I'm going to be posting. Alright, so if you have any questions or you would like me to help you in math, physics or chemistry, feel free to contact me using these lines on the screen. Let's proceed. Alright, so this is the question that we've been asked, and it's asking us to find B complement, A union B, A intersection B, A union B complement, and rather A intersection B complement and C minus B. So this is a very simple question. A has been given, B has been given, C has been given, and the universal set has been given. So to find B complement is simply just a set that contains elements that are in the universal set but are not in B. Yeah, so elements, in short, we are listing the elements that are not in B but they are present in the universal set. So B complement, you first have to look at set B. So set B is 2, 4, 6. So we're going to list the universal set excluding 2, 4, and 6. So we have 0, we have 1. So we are going to leave 2. We have 3. We'll leave 4 because it's in B. We have 5. We're going to leave 6 because it's also in B. And we have 7 and 8. So this is our B complement. Let's quickly move on to A union B. So A union B simply means we are adding two sets, we are combining two sets, set A and set B, and when combining these two sets, we have to make sure that the elements that are repeating or that are in both A and B are only listed once. So this is what we are going to do. So we can combine set A and set B. So set A is 1, 2, 3, 4, 5, and set B is 2, 4, 6. So the elements that are repeating or that are common, we just have to list them once. So we combine set A and B. So we have 1, 2, 3, 4, 5, and 6. This is A union B. Let's move on to A intersection B. So A intersection B is simply just the combination of the listing of the elements that are common in A and B. So we have to look at the common elements that are in A and B. So what is similar or what is common in these two sets? So we know that set B is 2, 4, 6. Set A is 1, 2, 3, 4. So the intersection is therefore, we know that 2 is in set A and it's also in set B. So we write it there because it's common. 4 is in set A, it's also in set B. We also write it there. So this is our A intersection B. Let us now find what this set is, A union B complement. So A union B complement, this means that the elements, we list the universal set, excluding the elements that are in A union B. So we can list any element that is in the universal set, excluding the elements that are in A union B, which is this one here. So A union B is 1, 2, 3, 4, 5, 6. And the universal set is starting from 0. So our first element will be 0 there. And we are going to leave out these elements and write the remaining one. So we have 7 and 8. So we write 7 and 8 there. We move on to A intersection B complement. So A intersection B complement, we are going to list the elements that are in the universal set, but they are not in A intersection B. In other words, we're going to list the universal set excluding these elements there. That's what this means. So we have 2 and 4 in A intersection B. So we're going to list every other element remaining in the universal set, which is 0, 1. We leave 2 because it's there. and 3, we leave 4 because it's there, so we move on to 5, and then we have 6, 7, 8. Let's now move on to the last part of the question, which is C minus B. So C minus B simply means we are listing the elements that are in, okay, let me simplify it for you. Let me just say C minus B is just the same as C intersection B complement. So C minus B is just the same as C intersection B complement, meaning we combine, or rather we find the common elements between C and B complement. So B complement is this set which we have here, and C has been given as 3, 4, and 5. So we have to look at the common elements between C and B complement, which is here. So when you look at this B complement, we have 3 there, which is also in C. So 3 is part of our set, and we have 4 in C. We don't have 4 there in B complement, so we can't write it. We have 5 there. It's also present there in C, so we write 5. So what I wanted to tell you is that when you have been asked to list C minus B, so C minus B is simply listing the set C, excluding what is in B. So in other words, you are subtracting B from the elements that are in C. That's what this means. So this is the solution. Alright, so this is the end of this tutorial. Don't forget to subscribe. Click on the subscription button so that you don't miss out the videos that I'm going to be posting. And if you have any questions, or you want me to help you in physics, maths, biology, chemistry, feel free to contact me using these lines on the screen. My name is Harmtedy. See you in the next tutorial video. Shalom, shalom.